as well. Sorry. Yeah, I'm sorry. And we use, by the way, propylene in liquid form, but ethylene in gas form, as most of us have already known, it's so difficult to like liquefy ethylene. You need to compress it and make it like give it more pressure in order to be compressed and get liquid. So we use ethylene gas and propylene in liquid form as our raw materials. And in every plant, you can see some towers, or you can call them like columns like this. So these are the purification units. So, before going into the main process, raw materials are purified using some processes like as simple as some filters, like filtration process, or any other types of separation, using some adsorption units. It's also kind of separation, or maybe as simple as drying, like getting the moisture out the raw material. So, okay, I gave examples from our plant again. So this is called adsorption dryer. The working principle is like we have some hygroscopic material inside these columns. Sometimes they're called like packed beds. So the materials inside are called molecular sieves. They are like small particles with like many small pores on that can absorb the water. So we use this for either propylene or ethylene to make them dry, to make them like water-free, moisture-free. The chemical compounds inside this catalyst, inside this columns are basically like aluminum oxide or silicon oxide based chemicals. Mixed bed. Yeah, this is called mixed bed. It's a mix of cation and anion resins. You can see the layers of anion resin and cation resin. They're all like both together in one column. So the cation resin, of course, will try to attract the positively charged ions like calcium or potassium, and the anion resin will try to attract the negatively charged ions like sulfates, chlorides, or nitrates. Anyway, and when they are fed enough, they can be regenerated and we can use them again. For regenerating them, we use, as it's written here, sodium hydroxide, and we use some strong acid also to regenerate the cation resin. Is most of the time sulfuric acid. So with this unit, we try to purify the water, the process water. We call them process water. So by this unit, we can get the ions, and then the process water is called demin water. It stands for like demineralized water, like ions-free water. Okay. And also we have activated carbon filters. I think you've already heard this. In water treatment units, activated carbons are mostly used units. So simply we have some activated carbons, like activated means like small, like cuts in small pieces, carbon materials, and they have again so many tiny pores on that to absorb the some chemicals like chlorine, phosphate, and making the water clean. It's mostly used for like tap water for like daily usage. But we also use this unit, like before mixed bed, we use this unit to purify our process water. Then we use it in like a process aim, not for washing or like tap water. Okay. I will talk about recovery section first, then we can, sorry. Okay. I will talk about the recovery section first, then we can come back to the reaction section because it will be a bit complicated. So after the main process, as we've said before, unreacted material is recovered and to be returned to the main process using different types of separators. So as I've said before, recovery is to just increase production yield or to increase what we call as conversion. So maximum usage of catalyst or raw materials in order to get like as much amount of desired product as we can. So these are the separators you can see on the photo. I think I have some problem. Okay. So this is one of the types of separator. It's called two-phase separator. You can understand from the name, it just is used to separate two phases, like either liquid or gases, or maybe solid and liquids or solid and gases from each other. This separator is used to separate. And in the photo, you can see gas and liquid separator. So you can imagine it as simple as like distillation column where liquid and gas are together and they're separated by like temperature and pressure difference. And then the liquid comes out from the bottom side of the unit, like based on gravity, and the gas flies up all the way to the top of the column, and then it goes out from that area. And also there's a separator type called three-phase separator, and that's just to separate materials in three different phases. So okay, by the way, we have this separator in our plant. So let me explain first and I can come back to example. So as you see, it's written well fluid inflow because it's for well flow. The photo is taken from internet. So like the mixed flow of oil, some natural gas and water together is sent into this separator. And then according to their density, like the density difference, oil of course stays at top, and water goes down. And this middle section is called emulsion layer. That means both water and oils, like the meeting area, they're both present there. And then as the level increases, oil goes like overflow this thing, and then gets to this section, and then from here oil can go out, and from here water can go out, and also gas of course flies to the top as being in two-phase separator, and then goes out. We use this separator in our plant. We, like as I've said, we produce polymer, more exactly polypropylene, and sometimes we get some low molecular weight, like with short polypropylene chains products, and they are called oligomers, like not polymers but oligomers. So oligomers are like oils generally. So we use three-phase separator to separate hydrocarbon gases, to separate water, and to separate those oligomers like oil in the photo. We use the separator for such an aim. Also in recovery section, there's a unit called scrubber. We used gas scrubber, so that's why I will talk about gas scrubber. So this is the unit itself. So raw gas coming into this tower, and then there's a scrubbing liquid. It can be water or maybe something else, but we use water in our plant. So we use this scrubber like after our unit, which is called dryer. So after drying our product, we get some hydrocarbons, and we get some small tiny particles of polymers. We call them fines, like tiny particles. So we don't want to have them in the clean gas section, which is coming from the top side of the gas scrubber. So we have, for this purpose, we have scrubbing liquid. It's water in our plant. So water is continuously circulating here, and gas together with fines coming inside the tower, and then water just helps to remove those particles and let them settle down in the scrubber. And by the time there's a level here created, and then we stop the process, open it, empty it, and like wash it back, and then we can use them again. So gas scrubbers are just used for this purpose. And there's also cyclone. So by the way, I've said our polymer dryer. So before the scrubber, like between gas scrubber and between our polymer dryer, there's a cyclone also we're using there. Cyclone is something based on an interesting physical fact. So we, by the way, we use nitrogen gas in our dryers and to dry the polymers, and then we have, of course, nitrogen flows from top of the dryer, top side of the dryer, together with fines, of course, the small polymer particles again, and then we send it directly before scrubber. We send it into the cyclone. This, like in the photo or GIF, you can see the yellow particles, and you can see some white particles. So yellow particles are solid particles, so you can imagine it like our polymer particles, and the white particles are like nitrogen. This is called a vortex effect. So when it comes like in radial direction, it just flows, and because of their density difference, solids are going like close to the chamber walls, so it flows all the way down because of the gravity, and then vortex effects like take action and let the gas go up all the way from the middle, like in the middle, inside the middle. And then by using this method, we again separated nitrogen and our particles, solid particles, with this method. Okay. Now we are on the reaction section. So in reaction sections, I decided to talk a bit about different types of reactors. I mean, the only ones that I have experienced. So the first one is CSTR. You've already heard that. I mean, you might have heard this name. It stands for Continuous Stir Tank Reactor. So as you can see from the picture, there's a stir and there's a continuity, meaning you can add like inputs, like feed your raw material inside the reactor continuously, and you can get your product from the other side continuously, and there's a stirrer inside, so that the conditions inside reactor is always on a steady state, so they don't change by the time, so you can continuously feed raw materials in and get your desired product out. And okay, I've given a picture here. This is kind of like a CSTR, but we don't have any stirrer here. So this is, we call loop reactors. This is what kind of reactors we have in our PP plant, polypropylene plant. We have a small reactor here. It's called baby loop, or it's sometimes called pre-polymerizer. And then we have two polymerizers reactors, like where main polymerization reaction happens. So these are the types of like continuous reactors. And we have here also pumps. By the way, they are axial pumps. We will talk about pumps, and I will cover it again. These are axial pumps. These are just to like maintain the polymer, and we call them slurry, like polymer and hydrocarbon together. So to maintain the slurry circulation inside the reactors, we have axial pumps. We have also a pump in baby loop, but it's not shown here. And also there's a kind of type of reactor that's called FBR, stands for fluidized bed reactor. In fluidized bed reactor, there are some raw materials which are in solid form, as you can see here, and also gas is given from the downside of the reactor, and this gas move the solid particles and make them act like fluid. So this is why it's called fluidized bed reactor. And we use this reactor in our plant as well. We call this reactor GPR, stands for gas phase reactor. So in loop reactors, as I've shown before, in loop reactors we produce some like solid particles, of course, using liquid propylene, and then we can send them to this reactor, the products, and we can give some gas for propylene, ethylene, and sometimes hydrogen, make it like fluidized bed, and then we can get some product which is type of, we call them copolymers. So in production of high density copolymers, to be more exact, we use gas phase reactor, and it's one example for fluidized bed reactor. And then either in raw material section or reaction section or recovery section, anywhere, we use some equipment. So I've tried to put together like some examples from those equipment that we use in our plant. So the first one is the simplest one, I guess, a pump. That is the a device which is used to move fluids by increasing their trying to decrease their volume, actually, because they're not gas, trying to decrease their volume, like compressing it and increasing their pressure and moving it from one place to another. So one popular type of pump is centrifugal pump. It's as a mechanical device to move the fluid by means of rotational energy from one or more driven motors. So as you can see on the right photo, you can see the photo of impeller. It's called impeller. So fluid, the suction side is here, like it's on axial side, is perpendicular to the impeller. So as impeller rotates, it kind of creates some suction in the inlet of the pump, because it increases the velocity and increases the like what's called velocity pressure inside the pump. So this is why there's a suction created at the inlet of a pump, and by this way it can generate high pressure for fluids. Again, I'm trying to not go into the details. Like centrifugal pumps, you should be careful with something called MPSH. You have to always remain your MPSH available more than MPSH required, or you can experience something called cavitation. So this is another type of pump, which is called diaphragm pump. Diaphragm pump is kind of like it's a type of positive displacement pump. So then it's not rotational, but it's called positive displacement. So as you can see in the picture, as this shaft goes up, it just pulls back the diaphragm and make the volume inside decrease. So created a suction, and then this valve open. It's like the inlet of the pump, and when it like compresses back, volume decrease, and this valve opens, and this is the outlet. Positive displacement pumps are actually used to like maintain constant flow, and also they're mostly used for some liquids that have more viscosity. So we use this pump for pumping oil in our plant. Yeah, axial pump. You remembered it. In our loop reactors, we had some axial pump. So it's called axial because the inlet and the outlet direction of fluid through this pump is on the same axis. It's not like perpendicular to each other as it was in centrifugal pump. So it's on the same axis. So it's called axial flow pump. And this pump is not actually used to create higher pressure because it cannot. It's something like a simple fan, but it can like increase pressure a bit in order to maintain flow, in order to maintain circulation. So in our reactors, we have these axial pumps in order to maintain the polymer and hydrocarbon, like we call them slurry together, the slurry circulation inside the reactors, like in order to have enough residence time. And a compressor. Compressor is simply some kind of device like pump, but it's used for gases, not for liquids. So it's a kind of device that increases pressure of gas by reducing its volume by compressing it. By the way, this pump is this compressor is a reciprocating compressor. We have this compressor in our plant in order to use it for propylene gas, not liquid propylene, but propylene gas. Of course, this is a compressor, and some ethylene. When we use ethylene, we use these reciprocating compressors in our plant. And there's also a kind of compressor which is called centrifugal compressor. It's so much similar to the compressor centrifugal pump. You can see the inlet and outlet direction perpendicular to each other. One is axial, the other one is radial, and the same structure inside the impeller. As it rotates, it increases the fluid velocity and the velocity pressure, and it kind of creates some suction at the inlet of a compressor as it does in pump. This is a simple blower. It's called blower, but it's like centrifugal compressor. The only difference is air. The blowers are used for some small capacities, like it can only help to maintain flow, but it cannot create so much pressure. So we use, and this one is air blower as it's written on the case, but we use air blowers, and also we use nitrogen blowers in order to transfer our product. Like, okay, at the end of the section, I will show you the photo of polypropylene, what we call polypropylene pellets and polypropylene powder. So in order to transfer them, we use air blowers and nitrogen blowers, like make them flow inside the pipes for transferring the air. And this is the reciprocating compressor, as it was on the first photo of compressor section. So as you can see, it's so much similar to the diaphragm pump. So it has some volume. So as this crankshaft goes back, the volume increases and creates some suction on this side, and the suction valve opens and let the gas go in, and then it comes back, compress the gas, and the volume decrease and pressure increase, and of course discharge valve opens and let the gas out. And let's talk a bit about heat exchangers. As most of us have already known, heat exchangers is a unit to transfer heat between two or more fluids. We call this heat transfer. So there are two main types of heat exchangers. One is plate heat exchanger, the other one is tubular, or as it's called, like shell and tube heat exchanger. So this is the photo of a plate heat exchanger. So it's just use metal plates to transfer heat between these fluids. We call them, we call this cold fluid and hot fluid. If it's a cooler, then the process side is hot fluid, and the another side is cold fluid, and basically it's called cooling water. So the other type is shell and tube heat exchanger. It consists of a number of tubes, as you can see, these tubes. By the way, this metal piece is called baffle. It's just used to help to keep the tubes together inside the exchanger. And then this bigger side, the whole exchanger, this side is called shell side. So one fluid flows inside the shell side, and the other one flows inside the tube side. And I will again talk about them and their issues. And then this is extrusion. I don't know if you've heard about it or not. So extrusion is okay. We use extrusion process. The unit is called extruder. We use extrusion for. I mean, after we get our product, they're recovered, and after degassing section, and then dried. So our pure product are sent to extruder, and then in extruder, as you can see in the photo, they are in some screw. There's a screw there, as it rotates, it also mix and it also transfer the melt throughout the extrusion unit towards what we call die plate. Die plate is like a circular metal with small holes, many small holes on that. Then this melt flows out like a spaghetti, and then as it goes out, it mixes with cold water, and cold water solidify it, make it solid, and then it mixes with knives, rotating knives. It just cut it. So also before extrusion, we've added some chemical compounds. We call them additives, chemical additives. They have different aims, to prevent pre-oxidation of polymer, or to prevent it from sunlight, or to prevent it from to increase its heat stability. So we used chemical additives. So in extrusion area, they are all mixed and melted. The temperature is around 200 and 230 degrees Celsius there. It's all mixed and melted and transferred and then cut. And then we have here what we call PCW, stands for pellet cutting water. So water solidify, and also it transfer the cut pellets to the separator, dryer, and then we have classifier, and then finally we will have our product. So extruder makes our product in form of granules. We call them pellets. I will show you in their photo. So extruder help us to have those granules in the similar shape, similar form, and similar weight, like which is important for us in order to bag the materials and have like the same amount of polymer inside each bag. And then this is the bagging area of our polymer plant. You can see this photo is taken in Soccer Polymer, actually, in our plant. And this is like a general photo of warehouse where polymers, after packaging, they are stored in warehouse. And this is like a general photo. So packaging is just like enclosing products for distribution and sale and stuff like that. So this should be end of the like process operation, and yeah, and I would like to talk a bit about some problems, some issues that we faced so far in our plant. We can call this section as troubleshooting. So one of the popular like one of the famous problems is falling off heat exchangers. So as you can see on the photo, this is a plate type heat exchanger photo. This is one plate, and you can see, if you look at carefully, you can see the clean side of the plate, and as well as the the dirty side. And also in this picture, you can clearly see that dirt on the plates. So it's because of dirty cooling water and lower velocity. So this exchanger is actually used in our extrusion area. So as I've said, we have had, let me show you that photo again. So we had here, you can see this blue part is water. It's called pellet cutting water. It's used for solidifying the melt, for cutting, and it's also used to transfer pellets for the further actions. So this water, of course, meets with some high temperature melts, and by the time it's getting heated up, so we have an exchanger, or simply cooler. It works with cooling water to cool down this water. So this is a photo when that exchanger was full and didn't operate normally. So we had to open, like dismantle this heat exchanger and wash it with some chemicals and make it usable again. So this photo is taken at that time. In cooling water sign, like reasons can be different. Like cooling water can be dirty. So for these purposes, like for cleaning cooling water, we use 3 types of additives, chemical additives. It's called biocide and anti-scale and corrosion inhibitor. Like biocide is used to kill some like bacteria inside the cooling water, and anti-scale is used to like chemically remove some ions like calcium, magnesium, in order to prevent the further scaling of them, those salts. And also corrosion inhibitors are a type of chemical compounds that are used to decrease corrosion rates of materials in which cooling water is flowing. And of course, lower velocity is another reason. So as fluid flowing inside the cooling side of heat exchanger, as the flow decreases, the velocity also decreases, and that like give the chances for scale forming or corrosion or anything that can collect on these pellets. So right now we're working on some change in our plant related to this extrusion. So we have had actually a PCV, that's or TCV, like temperature controlling valve, like a control valve. So in order to control temperature of water, we had a control valve on cooling water side. So whenever this water coming from extruder is hot, we need to cool it down more. So this valve opens more. But when no need, then this valve will close the cooling water and decrease its volume, meaning decrease its velocity, so that then can arise some problems of heat exchanger falling. So right now we're working on a change to remove that control valve from cooling water and put it on the process water itself, like a bypass of heat exchanger. And whenever we need like to cool down process water more, then bypass valve like will close it and let the more water flow through the heat exchanger in order to be cooled down. And when no need, then bypass valve will be opened, and this control should solve our problem. And this is also falling of heat exchanger, but this is tube type heat exchanger, or we can call shell and tubes type heat exchanger. Again, dirty process fluid, but this time we're talking about shell. So this is another reason can be fins. Fins is what we have. Okay, the photo on the right, you can see some metal pieces on these tubes. They are just to increase. They're put there to increase total surface area in order to increase heat transfer rate, but also they have some downside, like they can cause falling of heat exchangers. So let me tell you again an example from our plant. We have a U-tube heat exchanger, as you can see on the left side, the green one, heat exchanger. We have this fluid in polymer drying section. Again, we use this heat exchanger like a heater. So through these tubes, high temperature steam is flowing. And in the shell side, we have nitrogen that is going to be used for drying the wet polymer inside dryer. So we don't have any problem with steam. We don't have any problem with tube side. But in shell side, because we have some fins on these tubes, it's not shown in this picture, but you can see on the right photo. There are so many fins on these tubes. So, and of course, nitrogen coming like from dryer back to the heater. Again, it's kind of nitrogen circulation for removing the water or for making the product dry. So nitrogen coming back from dryer brings some small polymer particles. We call them fines, and those fines can be collected on the like tubes and fins of this heat exchanger. And by the time we had to dismantle this exchanger as well and wash it, clean it, and washing it is also so difficult because of so many tiny fins you can see there. Okay. And also we have some falling of reactors. We can say falling of reactors. This is something related to exactly polymer industry. That's the reasons can be deposition of oligomers. As I've talked about it before, oligomers are like polymers, but having shorter chains or like lower molecular weights, and also buildup of electrical charge in small polymer particles can also be reason for falling on the reactor walls. And also reactor walls surface cannot be like perfect, so a little bit of roughness on reactor walls can cause this problem as well. We haven't actually experienced this problem, but we have another plant called high density polyethylene. It's HDPE manufacturing plant. They have faced this issue, so I've heard it, but we've not experienced it personally. So try to put it here. And plug lines. Yeah, plug is one of the like big problems in polymer industry. Either slurry plug or pellet plug. So yeah, on the right side, finally, you can see pellets. This is called pellets. This is what we have after the extrusion process. These are just, okay, these are like polypropylene polymers in pellet forms, in granule forms. So this is extrusion product. On the left side, you can see this is what we called slurry, or they can be in melted form, so it depends on the temperature of the condition. So slurry plug happens slurry is what we call our powder, like maybe some unreacted or not completely reacted catalyst particles, and also hydrocarbons together with co-catalysts, together with hydrogen inside the reactors. Like all materials are circulating like a fluid, and we call them slurry. And in some emergency cases, we face this slurry plug. For example, when an emergency of high temperature happened in our reactor, we have to what we call dump the reactor, like discharge all the material out, or otherwise they will stay inside and get solidified and plug all the reactors. Then it's gonna be a much bigger problem for us. Like the emergency system, we call them interlocks. We call them actually emergency shutdown, ESD interlocks. So some interlocks have some problems for discharging the reactors. Some valves will stay closed, and on that valve, slurry like cannot go out, so stay there. And as the temperature, as the time goes and temperature goes down, they get in solid form. And sometimes because we have some axial pumps inside our reactors, some slurry, I mean, after emergency happens, some slurry can settle down because the pump stopped due to the emergency, and can settle down, and pumps are still hot and they can melt and like cover all pumps, impellers. Then we again have to open reactors, dismantle it and clean it. And it's a big problem. And also pellet plug can be experienced in polymer plants. So on the right photo, you can see these are pellets. And as I've told you before, when I was talking about blowers, we use air blowers and we use nitrogen blowers. Okay, let me explain. We use nitrogen blowers for what we called powder. Powder is our product coming from dryer that are not sent to extruder yet. We call them powder. They're like small spheres, and I will show you photos. And after extrusion, of course, some chemical additives are added, melted together, and cut in the same, like similar shape and weight. So these on the photo, right photo, they are called pellets. So in order to transfer powder, we use nitrogen blowers. In order to transfer pellet, we use air blowers. Why nitrogen? Because after dryer, we still have a probability of having some hydrocarbon like together with our powder. So we don't want those hydrocarbons meet with oxygen yet. So we use nitrogen blowers. But after extrusion, of course, we don't have any hydrocarbons inside. So we use air blowers in order to transfer the pellets or powder in powder case. And once this emergency also happened, so after extrusion, we sent our pellets with air blowers through the pipes to bagging area for packaging. And once this compressor set value was high, like 1.4 or 1.5 like atmospheric pressure. So that was like higher than the normal. Normally 1.1 or 1.2 bar is enough for transfer. So and an emergency happened, and pump stopped, the compressor stopped, and then this high pressure on pellets, of course, it just presses it through some, let's say, okay, like in bagging area, because the lines are like with smaller diameter. So this high pressure on pellets are like creating a problem of plugging, and then in bagging area we had to open the lines, and dismantle it, and like physically take the pellets out, and then clean the lines finally. So this is a pellet plug issue we have. Yes, that's the end.